In last session, we have seen interfacing of L293D. Now we have to connect this L293D with our STM32 controller, and we are going to see why we need controller and what else we can do with this. Okay, so we are going to remove these inputs. So these we are going to feed it using blue pill. So let's put it over here. Now what we are going to do, we have to match the pin numberings of our L293D with the motherboard we have designed. So let's go through this motherboard. Okay, so here in 1, in 2, in 3, in 4 are mentioned. Let's see which pins these are connected. So in 3 is with B6, B7, B8 and B9. Just the thing is that here in 3 is first, then in 4, in 2 and in 1. Like this, in 1, in 2, in 4 and in 3. So like this our design is. So let's jump to the designing part. So let's connect first B9 with in 1. So here B9, we're going to connect it with in 1. B8, we are going to connect it. Let me hold it. Let's drag this little bit up. Okay. B8 with into B7 with in 4 and B6 will be with remaining pin, that is in 3. Okay, so why I've done this complex pin numbering or attachments? Because it was easier for designing the PCB. Okay, to avoid the jumpers. So what why I've done it like this? So the tracks were getting proper paths. Okay, so to avoid the jumpers. Okay, now further, what we have to do? We have to connect the inputs. So what we are going to do? Let's consider from PA0 to PA4. Let's consider this PA3. Okay, so let's take these pins, or we can start from PA1 also. Let's go for PA1. So here, as a switch, we are going to attach the toggle logic. So PA1, PA2, PA3, and PA4. Okay, now what we can do actually, we can arrange it like buttons or remote control of the robot. So first PA1, so let's make it as forward switch, then PA2, so it is right switch. Let's give a little bit of space to them. So PA2 will be right, PA3 will be left switch, and PA4 will be reverse. Okay, let's see how it works. So PA1 will consider it as a forward switch, PA2 will be right switch. Okay, no, PA2 will be reverse switch. So this reverse will be for PA2. After that, we are having PA3. So it will be the left switch. PA4 will be the right switch. So it will look a little bit like a remote controller. Okay. So now these things has been done. Let's save this. Our output is connected properly, our input is connected properly. Now what is remaining? So now we have to do the coding for the same according to these pin numbers. So inputs are PA1 to PA4, outputs are B6 to B9. So let's jump to our STM. Okay, so here we are going to create a project. Let's name it new project. So you can use same diagram for Bluetooth controlled robot. You can use same diagram for RF controlled robot. Okay, so in both the cases the diagram will remain same and the code will also remain same. STM32F103C8T6. So let's take this one. Okay, here I'm going to name it as robot. Click on next. Let's finish it. Okay. Now PA1 to PA4, we have to make them as input as they are our switches. PA1 input, PA2 input, PA3 input, and PA4 input. Now you have to keep in mind, in case you are using UART2, so these pins cannot be used. Okay, PA2 and PA3, they will be under the UART's control. So in that case, you have to avoid using these pins. Okay. So while doing the programming of project, you should keep in mind that your pin function should not overlap. In that case, it is going to show you error. Okay, in this GUI only. So next PN6 to PN9, we have to make them output. So PA6 output, PA7 output, PA8 output, P, PB9 output. So from PB6 to PB9, we are going to make them as output. So this much configuration we have to do. So let's save this. Let's generate the code. Okay, so our code has been generated. Now here, you have to just declare the variables, not much complex stuff. So inside while one, let's delete this part. Now here, what we have to do, u int kate underscore t. Okay, so I'm going to name it as forward, that is f is equal to hal underscore gpio underscore read. Okay, now you have to take precaution that you don't need to type all the things, because if you're typing everything on your own, the chances of including typing errors will be more. So this is GPIO-A, we are going to use GPIO-A port. So here GPIO pin. So this pin will be pin 1. Okay. So we are reading these pins. So we are going to read PA1 to PA4. Now first pin is forward, second is for reverse, third one will be for left, and last one will be for right. So for right we are going to use RT because R is busy with reverse. Now let's change the pin numbers. So 2, 3, 4. This part is done now. Now further what we are going to need, we have to check status of each pin, and accordingly what we are going to do, we are going to run the specific motors dedicated to specific buttons. So first we are going to write only one loop and we are going to copy paste that further. So if f is equal to 1, yes, so if the first switch is pressed, in that case what we are going to do, we have to write date on specific motor pins. So GPIOHL, GPIO underscore write. So right pin here, what we have to mention, GPIO port B or we are going to use. So port B here, pin number 9 is here first, correct, pin state. So here in this case we are going to write it 1. Okay, so let's see why we are writing 1 here. So let's copy this. We are having 4 pins for motor. Okay, so motor 1 positive pin, that is for clockwise. Motor 1 negative pin, that is for anti-clockwise. Motor 2 positive pin for clockwise. Motor 2 negative pin for anti-clockwise. So okay, now here we are going to change the pin number 8, 6 and 7. This part is done. After this we are going to make 1 0 1 0. So here you can see that this is for left side's motor. Okay, suppose you can consider this part as left motor. So suppose left. Okay, so and here you can write right. So you can consider it like this. These are left motors, these are right motors, or vice versa. According to your adjustments, you can shuffle the pins, no problem. Okay. Now after this, so this one was okay. So if loop is done. Now what we have to do? It was for forward. Same we have to do for reverse, right, left, and in the end it will be the else part. Let's write else. In else everything is going to be 0. Means your robot will be in the off state. Okay, so if forward, if reverse. Now in reverse you have to reverse the polarity. Like for forward 1010 you are using. For reverse you have to use 0, 1, 0 and 1. This part is done. Now for left, what we are going to do? So we have to take 0 turn, means like the tanks turn on the same spot. Okay, they're not going to move forward like a car. Tanks are used to turn on their own axis, around it their own axis. So like that we have to design the turn. For that we are going to use 0, 1, 1, 0. Okay, and same way we are going to use for right. So here 1, 0, 0, 1. So 1001. So it is going to turn on the spot and this will remain 0. Now what we have to do, if we use just if, in this case what will happen actually, after testing the first condition, the C is going to check the second condition also. Okay, and if you press two buttons at a time, the code will, your robot will malfunction. So we are going to use else if over here. Okay, so if the first condition is true, second condition will not be checked. Okay, if any of the condition is true, its next condition will not be checked. Okay, so this part is done completely. Now let's build it. Let's check whether there are any errors. Okay, so no errors. So for hex file we are going to do the settings, C++ settings. Okay, now here what we have to do, post builds output. Here we are going to check the boxes for hex file, apply and close. Okay, now this part is done. So further what we have to do, just build the code again. So no warnings and we are getting the good H5. So let's move over here. And now what we have to do, let's upload the code. So for robot we are doing the coding, debug, H file, click on OK, let's run this. Okay, so if we press forward button, so all the wheels are running in the forward. Okay, if we press the reverse button, all the wheels are running in the reverse. For right, one set should be forward, other set should be reverse, and vice versa for left. Okay, so this is how you can make any robot. Now, what will change here? Okay, if you want to develop a wireless robot, what changes we are going to need? I'll show you that also. So the other projects that you can make is like this one. This one is a Bluetooth control robot. So here at input, what I have connected, I have connected this HC05 Bluetooth module. Okay, and I've used pins of serial communication. Okay, TX and RX pins. Okay, another option that you can prefer, you can use radio controlled modules also. So this was an garbage river garbage collection robot. In this here you can see I have provided the pins for radio frequency input. It is going to provide inputs for four keys, that was forward, reverse, right, left, like that. Okay, and you can see its PCB is something like this. So here is the PCB. In center we have microcontrollers, right, left motor, and one is for your lighting system was there, and one servo motor was there. So you can make RF radio frequency based robots also. For that you are going to need one module. So this one is your remote controller with small transmitter, and this one is receiver module. This part you have to connect with your STM32, and this will be in your remote controller. So you have to attach one battery and you have to attach four switches here. Okay, so it works on 433 megahertz ASK, that is amplitude shift key. And here this is for address configuration. So if you're in your classroom you are having 4 5 of these pairs, so there is chance of cross connections. So these are to configure your address. Okay, so both these switches should match and your address will match. Okay, so that specific receiver is only going to communicate with this transmitter. So this is how you can make multiple robotics project, like firefighting robot, surveillance robot is there. Yes, you can make a rough terrain robot. So there are many options. So it is quite simple. So you should try these things. Okay. So in next session we are going to see one more such actuator. Okay. Thank you.